Let's take a look at the Cipher cipher. It's a symmetric encryption cipher, so the same key is used to encrypt as is used to decrypt. This is something, if you were in second grade and you wanted to send an encrypted message to your friend, you might have used the Cipher cipher already. Your decoder ring basically implements the Cipher cipher. It's made famous. It's called the Cipher cipher because Julius Caesar actually used it for military communications. So this goes back a very long ways. It's not strong encryption, but it does demonstrate a lot of principles of encryption. So it's useful just to take a look at it. It's not strong. It should not be used for sensitive communications today, but we can play around with it, see how it works. It's known as a rotation cipher. So think about your decoder ring and you're rotating that decoder ring and you've got, the alphabet on the outside and then another alphabet on the inside and you rotate it so every letter matches up with another letter. So if we had that decoder ring when we had all the letters lining up, A lines up with A, B lines up with B, etc., there's no encryption. But if we rotate our dial on our secret decoder ring one position, now B lines up with A, C lines up with B, D lines up with C, etc. And then A lines up with Z. So every letter will have a corresponding encryption. So the key in this case is the amount of that rotation. So the algorithm is to rotate. The amount of rotation is the key used. So if we rotate that our secret decoder ring twice, then the letter C corresponds with A, etc., etc. That's basically what we're doing. So let's play around with this. One tool that I like to use is the Cyber Chef. The Cyber Chef, there's a link to it. You can Google Cyber Chef. It's open source. It's good, implements lots of cybersecurity algorithms, hashing, encryption, keys, networking, tons of great stuff. It's a tool I use very frequently. We have operations, we have our recipe, we have an input, and then we've got the output. So let's say, for example, in the input, I'm going to put the word FACE. That's the message I want to encrypt. Right now I've got no recipe doing anything, so my input is being run through the recipe, which does nothing. And then I get the output, which is the same as the input because nothing was actually changed. Let's find the Cipher cipher here. So in the operations, the easiest way is just to search. You can search Caesar and you get a few different hits here. You got Bach cipher, Rot 13, Rot 47, the Vigenère. What we want is the Rot 13. This is the easiest way just to get going with the Cipher cipher. This is a simple Cipher substitution cipher which rotates alphabet characters by the specified amount. The default is 13, so that's where the 13 and Rot 13 comes from. So I'm going to throw Rot 13 in there. So now the input, I didn't change the input, but my output changed because now the input is going through my recipe and I'm getting the output. And I see the number of characters being rotated here. And I can change that. I can change this amount up or down. So if I change this amount, let's go back to 0. So a rotation of 0, that's turning that dial on our secret decoder ring, 0 characters. The input matches the output here. If we change that rotation, turn that dial, essentially is what we're doing by changing this amount, we see a different output here, LGIK. So I send that secret message to my friend, my fellow spy, whoever it is, and I have to communicate that key somehow. Maybe we've agreed beforehand, hey, you and I were always going to use a rotation of 6 in this case. So they know, they put that into the Cyber Chef. They put LGIK here, and they undo that rotation -6 in this case. So they do the opposite. And so they take the encrypted input and they produce the unencrypted output. So in the world of cryptography, the unencrypted data is plain text. Plain text can be images, can be actual text, could be a Word document, could be a movie, but we're still going to call it clear text. Plain text, clear text. I might mix those up. Clear text is the right term. I apologize. Cipher text is the encrypted data text in this data. So it's cipher text. LGIK is the cipher text. Face is the clear text. So we added ROT13, we ran it. Anytime you change the input, the Cipher Chef will automatically run that input through the recipe. If you have to hit the bake button, it will do it manually. Usually don't have to do that, but it doesn't hurt. I can click bake. This algorithm is going to run the same way every single time, so I could hit bake 1,000 times. It's going to bake this recipe the exact same way. So there's no randomness being injected into this process. Let's find this message. What does this, I've got this cipher text, this encrypted text here. I'm going to paste that in my input, paste it there. How do I know what that is? Well, I can brute force attack this. There's only 26 letters in the alphabet, so there are only 26 different rotations that this could be. So I'll start with 0. I'll start my brute forcing there. So my input matches the output. Then I'm going to change my super secret decoder ring, and I'm going to see if I can recognize some English here. I know my message is English because I created the message. Okay, so if I get to amount is 6, the Caesar cipher is really not secure. You should not use it to protect data. So I was able to brute force, decrypt, and find that clear text message just by trying different keys. You only have to search 26 of them, and eventually you're going to get the answer. Now this worked okay for Julius Caesar because Julius Caesar was sending these messages when literacy rates were pretty low across the world. So even if Julius Caesar did not encrypt anything, lots of people would see that message and just not even be able to read it. So just doing a little bit of obfuscation, even a very simple encryption algorithm, turned out to provide a decent level of encryption that protected sensitive information. Julius Caesar preferred a rotation of 3, it is said. Not that complicated, but the military commanders, they could figure this out. They could decrypt those messages. So encryption goes back thousands of years. This rotation cipher is simple, but it demonstrates that we've got an algorithm and a key. And that's what's providing us the encryption and decryption. So it's not strong. Don't use it. This is kind of a toy algorithm today. In cybersecurity, you can find capture the flag events that have messages encrypted with the Caesar cipher. It's a good one to be aware of. It'll get you a few points on that capture the flag. But really, we're just using it to learn some of the foundational concepts of encryption and decryption.